Now we learn what is called as the general equation of the circle, or the general form of the equation of the circle, which is the most important form, because that is used most often, and that gives us the different parameters of the circle. uh, let us consider the center radius form first, that is x minus h the whole square plus y minus k the whole square equal to r square, where h and k are the coordinates of the center and r is the radius. So suppose we expand this, so we get x square minus 2hx plus h square plus y square minus 2ky plus k square equal to r square. Now we will rewrite the expression in a fashion that first the quadratic terms are written, then the linear terms are written, minus 2ky, and now the remaining constant terms are h square plus k square, and bringing r square on left side it becomes minus equal to 0, right? Therefore we get x square plus y square. Now this minus 2h we write as plus 2gx, just for the sake of making it convenient and easy to remember. And here minus 2k we replace as plus 2f, right? And lastly h square plus k square minus r square ultimately together is nothing but some constant term, so that we replace with simply c and equal to 0. So this is what is called as the general form of equation of the circle. So just to recap, what we have replaced is g is nothing but minus h, and f is nothing but minus k, and c is nothing but h square plus k square minus r square, right? So this is a very important form of equation of the circle. Now let us see the important points regarding this. So the points to note regarding this general equation is, if you observe, the coefficient of x square term will always be equal to coefficient of y square term, and that is nothing but equal to 1. And additionally we observe that the xy term is always absent in the equation of any circle. So that's an important fact that we have to remember. Okay. Now when we say that coefficient of x square and y square both should be equal to 1, that is only in case of a general equation. That means when we write the equation of the circle in the general form, right? If at all they are not 1, that means suppose they are something like 2x square plus 2y square, right? In that case we divide throughout by 2 and then we get the general form. But in every equation the coefficients of x square and y square themselves will always be same. So that's an important takeaway from this. Okay. Now let us see how to convert a general form to center radius form, because from the general form, suppose we want to find out where is the center of this circle and what is the radius of this circle. So this is what we will derive now. Now the procedure to convert general form into center radius form is to collect all the x terms. So therefore we have x square plus 2gx, so I write it in a bracket, plus to collect the y terms, that is y square plus 2fy, we keep c as it is, equal to 0. Now we have to complete the square, because if you observe, center radius form means we have to bring it in this form, isn't it? X minus h the whole square plus y minus k the whole square equal to r square. So that means our job is to somehow arrange the complete squares or the perfect squares. So therefore if we have x square and 2gx, then we must add g square to it so that it becomes a complete square. Similarly in the second bracket also we must add f square to make it a complete square. And if we add g square and f square on left side, we must add the same on right side also. Correct. So therefore here the first bracket is nothing but x plus g the whole square, plus second bracket is nothing but y plus f the whole square is equal to, we take c on the other side. So that is where we get g square plus f square minus c, and writing precisely in the required form, because we want x minus something, right? We want to show it as a subtraction. But if we have x plus g, we write it as x minus of minus g, right, the whole square, plus y minus of minus f, the whole square, is equal to, and on the right side we want to express it as a square of radius. So therefore whatever is this particular quantity, that is a square of its own square root. So clearly we can write it as the square root of g square plus f square minus c under root and the whole quantity squared. So therefore now if you compare this with the standard form, that is x minus h the whole square plus y minus k the whole square is equal to r square. So this is where we get the relation between, or the connection between center radius form and general form. So here h is nothing but minus g, k is nothing but minus f, and radius is nothing but square root of g square plus f square minus c. So therefore looking at the general equation, we can directly write down what is the center, right? So that center is nothing but, in the original equation it was h comma k, so here in the general form, that means taking the coefficients from the general form, the center is at nothing but minus g comma minus f, and radius is nothing but square root of g square plus f square minus c. But it should be, of course, it is assumed that the term g square plus f square minus c is positive, because since it is under square root, it has to be positive only. Alright, now let us solve one example based on this. Find the center and radius of the circle whose equation is 2x square plus 2y square plus 3x plus 4y plus 9 by 8 equal to 0. Now we have to convert the given equation in the general form so that we can find out the center and radius. But for that we have to divide throughout by 2, because as we see the coefficients of x square and y square are, both are 2, and we want both of them to be 1. So on dividing we get x square plus y square plus 3 by 2x plus 2y plus 9 by 16 is equal to 0. Right? So if you compare now, this coefficient of x in the original is 2g, correct? So therefore 2g is equal to 3 by 2. That means g has to be equal to 3 by 4. And similarly the coefficient of y in the general equation is 2f, that is equal to 2 here. That means f is equal to 1. And the constant term c is nothing but 9 by 16. Now we know that the center is at minus g comma minus f. So therefore we get the center as minus 3 by 4 and minus 1. So we have obtained the location of the center. Now as far as the radius is considered, what is the expression for radius? Radius was nothing but root of g square plus f square minus c. Okay, so let us calculate that. So therefore R is equal to, G is nothing but 3 by 4, so G square turns out to be 9 by 16, plus F is 1, so 1 square is 1, and minus C is minus 9 by 16. So 9 by 16 gets cancelled and radius turns out to be 1. So this is how we find out the center and radius from the general equation.